Okay, I'm going to run a new part program. First thing I'm going to do is I'm going to tell it it's a new session. I tell it yes. Then I come over here, click the icon, I open the file I want to run. In this case, I'm going to run NuFlex. Open. It loads the part. It loads the program to the right hand side. Shows the last run. The red is where it failed in the last time I ran the part. Shows my graphics screen of my run. It also gives me a live video display. So I come up to my icon, I press the play mode, and ask me for a line. So the first line is going to be my skew feature to make sure the part's square on the stage. And if you go to the graphics screen, you'll notice that the blue highlight is telling me my skew line. So I'm going to come over to here, and I'm going to move up and calculate the skew line based on the reference edge it tells me in the reference drawing in the graphics screen. So I'll come up over here and move quick release. Move to my edge. Now the target tool is right there, so if I move the target tool into any position, or I just click it with the icon, it'll grab the point and marks it down in the feature list. And it's looking for 3 positions, so I'm going to take my second point, and I will take my third point. Make sure they're nice and spread out, so you get a nice reference edge. I hit done. It calculates the point and tells me to go to my line number 2. Now this line number 2, the blue line, is going to be my intersecting with my first line and create my datum. So as soon as I calculate this line, the machine will automatically calculate the datum for me. So I'm going to come over to here, and I'm going to hit my point, and go down a little further, and down right to the very end. You can always refocus if you feel like it's not focused enough. When you're done, you hit done. Now the machine knows where it is, so it's going to reference me to my third line there, which is called line 5. I'm going to move my icon. Now we want to follow the red arrow to the red target. Once we light the target, you'll see right here that the actual point is on the screen. When I hit go, it enters that point into the calculation of that line. So we're going to go to another position, and we'll put it in here, same thing, and we'll go to next. So the idea behind this is just going to follow the arrow to each position where it tells you to go, and then you're going to stop, click, and then proceed to the next point. This is going to give great repeatability between the operators and also take the right amount of lines every single time. And we're going to come over to here. So this one, instead of using the individual tools, I use my circle tool. And it grabs everything all the way around that diameter. Same thing with this one up here. I use the circle tool when I wrote the program. Focus there, and grab the part. Same idea here. Now this image here, I couldn't fit the whole circle on, so I just grabbed sections of the circle. You'll see it tells me where it thinks it should be, and it grabs the actual edge once I hit the green screen. See it? Jump to the edge, the red up here, right here. Jumps to that edge. Come over to the other side. And we're going to continue taking these inside diameters. Bear with me for a second. Go up here. So as I calculate these diameters, it's adding all any tolerancing that I might have put in here and evaluating these numbers. So as soon as it runs the program, it'll actually calculate my out of tolerance position and tell me which features are actually out of tolerance. Once you have that data, you can send the data out to your part. You can send it to an Excel. You can send it to a TXT file. Print the data off and put it in your packaging for your customer. Let's come up. A lot of points in this part. But the idea behind it is once you know and set that part up, it's going to know where to go. So if we come over to measure this part, now when I'm done with this part program, I simply need to load another part on. a few more measurements. So it's going to find whatever is in the field of view. This one's going to do a line, and then it's going to ask me for the radius and another line. Here's my line. Up to the radius. And down here to the other. So it's actually scanning the edge. It's not going to follow. This is where it thinks it should be, right here. But it's actually going to scan and find the correct edge when it measures. It does my measurement. It does my output. It flashes the screen. It tells you distance number 22 is out, and you'll see 1.964. If you look at the data, it actually shows you the deviation there. If you look at the output data, and we go down to the output, and it actually shows you the highlighted fail. So there's my different runs for the day. If I turn these on and say, well, let me see what my diameters were for these runs, I can switch them there, and I can actually look at some statistics and see what my repeatabilities are. So you're looking at a 5/10,000ths of an inch range. Across the diameter, that one's 4/10,000ths, and the diameter here is another 4. And my distance here is within the 10th. So, if I want to run this part again, I can simply come up here, and I can hit run. This is the part in the same location. I'm going to come over here, I'm going to grab another part. I'm going to put the part back on the stage. We'll tell it no. So now we're going to realign the part, and this is the reason you establish the skew and reference lines, because once you put this new part on, as soon as we establish these positions, it's going to know where to go. This one here, and here. Oops. So we set up the skew, we tell it we're done. Now for the intersecting datum line, like we did before. And right to here. Alright, done. And we now again we follow my arrow. Go up here. And you'll see now it's just walking me through the part like we did before. It won't do it all. Okay. So if we're finished, we looked at my data, and then it'll be all my feature data that we recorded in that last run. And that's how you run a part program.